Hello, curious sleep listeners. Welcome back to the quiet side of the cosmos. Before we begin tonight's journey, remember to leave a like, subscribe, and let your mind drift as we explore the farthest future of everything, the cold, final age of our universe. Now, close your eyes. Imagine time stretching forward, not for thousands or millions, but trillions of years. Stars fade, galaxies drift apart, and the glow that once filled the night begins to dim. This is where we are going tonight, to the end of warmth, the quiet horizon of existence, the cold end of the universe. The story begins in a time long after our age, after humanity, after Earth, after even the Milky Way has become a ghost of light. The stars that remain are old and red, burning slowly, each one living on borrowed time. For billions of years, these faint suns continue to shine, but their fuel is limited. Hydrogen, the simplest and most abundant element, is nearly gone. Fusion slows. The stars cool. One by one, they begin to die. Massive blue giants go first, collapsing into black holes or scattering their remains across space. Smaller stars, like our sun, live longer, fading into white dwarfs, then cooling into black, silent spheres. In this distant future, galaxies are no longer bright islands of color. They are faint smudges in a darkening ocean. Their stars are pale, their planets frozen, their centers cold. The Milky Way and Andromeda, once vibrant with billions of suns, have long since merged into a single galaxy. Milkdromda, a ghostly swirl slowly dissolving into the night. Even gravity, the quiet architect of structure, begins to lose its grip. Dark energy continues its slow expansion, pushing galaxies farther apart. Each island of light grows lonely, surrounded by nothing but blackness. From this moment onward, the universe enters what physicists call the degenerate era, a time ruled not by stars, but by remnants. White dwarfs, neutron stars, and black holes are all that remain, drifting through a darkness that grows colder with every passing eon. The temperature of space itself drops, once millions of degrees, then thousands, then less than a single degree above absolute zero. The cosmic microwave background, the faint afterglow of the Big Bang, fades into silence. There is no sunrise anymore. No new stars are born. The night has won. And yet, the universe does not end. It simply changes. Matter still exists. Gravity still whispers. Even in the absence of warmth, energy lingers, faint, slow, but real. Electrons still circle the remnants of dying atoms. Black holes still breathe softly, unseen. The light that remains travels endlessly through infinite space, never finding a home. It stretches thinner and thinner until it can no longer be called light at all. And so begins the long twilight of creation, the slow descent into eternal cold. It will not be quick. It will not be violent. It will be quiet, an ending so vast, so slow, that it can only be described as peaceful decay, the final lullaby of time. You drift now, weightless in the endless dark, and the faint hum of space begins to fade. The warmth of the stars that once defined everything is gone. What remains is the echo, the memory of brightness in a universe learning how to sleep. You are drifting through a sky that no longer burns. The stars that once filled the cosmos with fire are now fading, one after another, like candles in an endless night. The universe has grown old, and the light that once defined it has become rare, precious, fragile, temporary. The last generations of stars are red dwarfs, small, dim, but incredibly patient. They are the final guardians of heat, burning their fuel so slowly that they can live for trillions of years. But even they cannot last forever. Their hydrogen, a simple breath of the cosmos, eventually runs out. When it does, they cool quietly. There are no explosions, no violent deaths. They shrink, darken, and fade until they become black dwarfs, cold spheres of carbon and oxygen drifting through a frozen void. Imagine looking at the sky in this era. There is no blue, no gold, no shimmer, only faint red embers scattered across a field of black. Then, even those embers go out. Galaxies no longer glow. Planets, if they still exist, orbit invisible corpses of stars. The temperature of space continues to fall, approaching absolute zero, a place where motion itself becomes almost impossible. And yet, there is something hauntingly peaceful about it. The universe is no longer a storm of creation and destruction. It has slowed into stillness. The chaos that once filled it, supernovas, collisions, radiation, has gone quiet. What remains is balance. You drift past a dead star, a black dwarf the size of Earth, but heavier than the sun. Its surface is smooth and perfectly dark, radiating no light, no heat. And yet, beneath that silence, the atoms inside it are still locked in the memory of pressure, a billion-year-old echo of fusion. You realize that nothing ever truly disappears. Even when light fades, structure remains. Even when warmth ends, memory continues. In time, far beyond imagination, these black dwarfs might experience something remarkable. Quantum physics predicts that the protons inside them, the fundamental building blocks of matter, will begin to decay. It will take longer than any span of time we can comprehend. Numbers with more zeros than atoms in the universe. But eventually, even these dark stars will crumble into dust and radiation. The last traces of matter will vanish quietly, dissolving into the background of nothingness. No explosions, no endings, just silence. It's a kind of peace that feels both comforting and tragic. The universe that once blazed with light has grown old with grace. You look out into the dark. Where once there were countless galaxies, now there is only emptiness. The horizon glows faintly, not from stars, but from the rare collisions of old dying remnants. Brief flickers in the long night. It's strange to think that this is not the end, only a stage. The cosmos is patient beyond measure. It does not rush toward its conclusion. It drifts there. Every pulse of light that remains is a whisper of what once was, a soft reminder that the universe was once alive, burning, vibrant. You close your eyes and let that image settle. The stars, once singing with energy, now sleep. The galaxies, once spinning in chaos, now float like frozen leaves in a windless sea. And though the universe is fading, it is not gone. It is resting, storing its final breaths for what comes next. Because even when all light dies, one kind of energy remains. Invisible, powerful, inevitable. The dark is not empty. It is waiting. The last stars have gone out. No warmth remains, no light glows on the horizon. The galaxies that once filled the sky with endless color have dissolved into nothing but invisible dust. The universe has entered its next great era, the age of darkness. You drift through a space so black that the concept of distance begins to fade. There are no points of reference, no glimmers, no shadows, only the endless void. Yet not everything is gone. Some things remain. Some things endure when everything else fails. The rulers of this era are not stars, but black holes. They sit silently in the dark, the last titans of gravity, the remnants of collapsed giants that once lit the heavens. Their power is quiet but absolute. Around them, space still bends, time still slows. Even in the absence of light, their presence can be felt, invisible yet unmistakable. They are the last beacons of order in a universe that has forgotten motion. You approach one now, not by choice, but because gravity does not ask permission. The black hole looms like a shadow within shadows. You cannot see it, yet you know it's there. Its horizon curves through space, a boundary between existence and silence. Once, black holes consumed the light of stars, devouring suns in violent spirals of energy. Now, they consume what remains: dark matter, rogue planets, dust, and even the faint traces of radiation that wander too close. Every swallowed particle makes them grow, heavier and slower. More still, their hunger is endless, but their world has run out of food. The dark has starved even them. You watch as one drifts alone, motionless, its gravity shaping the void around it like a silent sculpture. Inside, time has nearly stopped. Outside, eternity passes without change. The black holes are patient. They have waited through every era, from the bright beginnings of creation to this quiet twilight. But even they cannot last forever. At their edges, something small but relentless occurs: hawking radiation. It's faint, weak, almost invisible, but constant. Over unimaginable spans of time, this subtle radiation will cause even the greatest black holes to evaporate. The process will take longer than anything that has ever happened. Longer than galaxies existed. Longer than atoms lasted. Longer than time itself, as we understand it. But eventually, they too will fade. Each black hole will shrink, becoming smaller and smaller until it releases one final burst of energy. A last, soft sigh of heat in a universe that has forgotten what warmth feels like. And then, the lights will go out for good. What follows will be true darkness. Not the absence of stars, but the absence of everything. No light, no matter. Only particles so rare that they might never meet. It's hard to imagine such stillness. A universe stripped bare of structure, of pattern, of noise. And yet, there is beauty in it. Because even in this endless cold, physics still whispers. The laws that shape the galaxies still exist, even when there is nothing left to obey them. Space still stretches. Time still ticks. The equation of existence still holds, though there is nothing left to calculate. You drift farther into the black, the last echoes of gravity fading behind you. The universe has reached its quiet estate, the reign of darkness. But this reign is not tyranny. It is rest. Every star that ever burned, every atom that ever existed has fulfilled its purpose. The cosmos, now empty, has become a monument to completion. And though it is dark, it is perfect. The black holes are gone now. Their final sighs of radiation have dispersed into the endless dark, faint ripples that travel through a universe too large and too empty to notice. Nothing moves quickly anymore. Nothing burns. Nothing glows. You are drifting through the quiet aftermath. The long, slow decline toward perfect stillness. This is the era of fading heat, the final chapter of thermodynamics on a cosmic scale. In the beginning, the universe was defined by imbalance. Energy rushing from hot to cold, from dense to thin, from creation to expansion. That difference gave rise to everything: the stars, the planets, even thought itself. But now, after countless eons, that imbalance has dissolved. Everything is the same temperature. Everywhere. The cosmic background, once brilliant with the heat of the Big Bang, has cooled to near absolute zero. The last faint traces of radiation drift evenly through all of space, their energy stretched thin beyond measure. There is no warm place left, no spark to ignite motion. The universe has reached what physicists call thermal equilibrium, or, more poetically, the heat death. It isn't an explosion or collapse. It's the absence of both. No energy flows. No stars form. No reactions occur. Even the subatomic dance has slowed to a near stop. At this temperature, fractions of a degree above nothing, even molecules lose their rhythm. Atoms rarely collide. Photons pass without interaction. The cosmos has become a vast, silent sea of potential that will never awaken. And yet, strangely, it feels peaceful. You float in that infinite cold, and it feels like being inside a great exhalation that never ends. The universe isn't dying, it's resting, perfectly balanced, perfectly even, perfectly quiet. If you could listen to it, you would hear nothing at all. Not because there is no sound, but because there is no contrast left to define one. Sound needs difference, a vibration against stillness, and here, everything has become the same. Time still exists, but it has lost its meaning. Without change, there is nothing to measure. Seconds, years and eons have merged into one long pause. You realize that this is not destruction. It's the ultimate symmetry. Everything the universe ever was has finally spread itself evenly across infinity. No corner is special, no moment brighter. It is equality, absolute and eternal. You pass through a region once filled with galaxies. There is nothing left now but faint radiation, evenly dispersed like a mist of forgotten warmth. The remnants of atoms drift slowly, no longer binding or colliding, simply coexisting in endless calm. It's difficult to call this an ending. It feels more like a conclusion, the final line of a story that was written perfectly from the start. The temperature falls one final fraction of a degree, and then it stops. Absolute zero, the point where even motion sleeps. The universe has no more to give, and so it simply is. A vast ocean of stillness. No light, no dark, no time, no space as we once understood it. Only balance, infinite, serene, and complete. You realize that you are witnessing the fulfillment of the second law of thermodynamics, entropy's long victory. Everything has reached its calmest possible state. Nothing more can happen, because everything has already happened. You whisper softly into the cold. So this is peace. And for a moment, the silence feels almost warm, as if the universe itself is whispering back. Yes, at last. You close your eyes. There is no need to see anymore. Everything that ever could be seen has been seen. Everything that ever could happen has already passed. The universe has found its final temperature, and with it, its first true rest. At this point in the universe's timeline, all structure has collapsed into simplicity. The stars have vanished, black holes have evaporated, and galaxies have long dispersed beyond one another's reach. What remains is the residue of everything that once was, a thin, almost invisible fog of subatomic particles drifting through the dark. The temperature of space has fallen to just above absolute zero, around 10 Kelvin. At this unimaginable cold, motion itself becomes rare. Atoms no longer exist as we know them. They have long decayed, leaving only their smallest components. Protons, neutrons, electrons, neutrinos, and photons. But even these final survivors are not eternal. Modern physics predicts that protons, which form the nucleus of every atom, will eventually decay. The exact lifetime is uncertain, but estimates range from 10 to 10 years. To put that into perspective, if each second since the Big Bang were a grain of sand, the pile would still be smaller than the time span of a single proton's life. When a proton decays, it releases lighter particles, electrons, positrons, and bursts of radiation. Over vast ages, these decays will erase the last remnants of matter itself. The universe will no longer contain stars, planets, or even dust. Only light particles, radiation, will remain, too faint to see, too weak to interact. Think of it like this: every solid thing that ever existed, every mountain, every planet, every atom in every star, will have dissolved into a smooth mist of energy. Matter, in the form we know, would be gone. Neutrinos, those ghost-like particles produced in nuclear reactions, will also drift through space in unimaginable numbers. They almost never collide with anything. Even in a universe full of matter, they could pass through light years of solid lead without touching a single atom. In this cold future, they move freely, unbothered, forming an invisible sea of motionless motion. Meanwhile, photons, the particles of light, will stretch endlessly with the expansion of space. Their wavelengths grow so long that they can no longer transfer energy in any meaningful way. What was once brilliant light becomes something more like thought, pure existence, too weak to be seen, but still there. At this point, the universe is a strange place. It isn't empty, but it is inactive. Energy still exists, but it is spread so evenly that nothing happens anymore. No gradients, no flows, no sparks. You might imagine it as a cosmic ocean so calm that not even a ripple can form. This is what scientists mean when they speak of maximum entropy, when energy can no longer move from one place to another, because everything is the same everywhere. Entropy doesn't mean chaos, it means balance. Perfect, irreversible, eternal balance. For the first time since the Big Bang, the universe has stopped changing. If you were to somehow exist in this age, if you could look out into that infinite dark, there would be no horizon, no starlight, no sound. You would see nothing, but you would still be surrounded by something. An invisible bath of low-energy radiation, the last whisper of the Big Bang, stretched beyond recognition. Now, take a moment to imagine that. A cosmos so old that even atoms are myths, so cold that the speed of thought would outpace the speed of light. And yet, the laws of physics remain exactly the same, calm, precise, and eternal. Nothing moves quickly anymore. But the universe itself, even in silence, continues to expand. It's not gone. It's simply resting in its final perfect stillness. The universe has now entered one of its final measurable eras, the slow disappearance of matter itself. Everything that once had structure, form, or identity is dissolving into fundamental energy. What remains are the smallest building blocks of existence, and even they are beginning to fail. Let's look closely at what happens here. Over the course of 10 to 10 years, protons, the particles that once formed the nuclei of atoms, begin to decay. Each proton transforms into lighter particles, such as positrons and photons, through quantum processes we barely understand. This is not an explosion, not a collapse, but a gradual fade. A single proton might exist for longer than every star that ever lived, yet it still has an ending written into its nature. As protons vanish, the structure of matter disappears with them. Atoms cannot exist without nuclei. Molecules cannot exist without atoms. Rocks, planets, and everything built upon them quietly disintegrate into clouds of radiation. It's a remarkable idea that the same forces which once bound the universe together will eventually erase it. The electromagnetic bonds that held atoms in place, the nuclear forces that powered stars, all yield to entropy's slow and patient work. The transition is not dramatic. There are no flashes of light or bursts of sound. Matter simply stops being matter. In the place of solid reality, a faint mist of subatomic debris expands through the void. Most of it consists of photons, light particles, and neutrinos, the quiet wanderers of the cosmos. They carry the final energy of what was once everything. At this point, the density of the universe is extraordinarily low. If you could somehow isolate a cubic light year of space, it would contain fewer than a handful of particles. And each of those particles would be separated by unimaginable distances, too far apart to ever interact. You might think of this as the cosmic disassembly, not destruction, but deconstruction. Every law of physics still applies, but there's simply nothing left to apply it to. The stage exists, the rules are still written, but all the actors have left. Still, there's something quietly elegant about it. The forces that once built galaxies have completed their work. Matter's great project, to form, to burn, to shine, has ended in perfect completion. And yet, there remains one final kind of object that resists this fading. The black hole remnants, some too large to have completely evaporated, still exist in the darkness, waiting for their last moments. They have outlived stars, galaxies, and even atoms. But their turn will come. The faint light that remains, this diluted fog of radiation, continues to spread outward with the universe's expansion. Its wavelength stretches until it becomes so long that it can no longer be detected. An ocean of energy too weak to measure. If we were to describe the universe now, it would be a place of extreme simplicity. No matter, only energy. No heat, only cold. No movement, only expansion. And yet, it is not nothing. Everywhere you look, there are still the fundamental traces of existence. Fields, virtual particles, and quantum fluctuations appearing and vanishing in the dark. The laws of physics still operate, even when there's nothing left to act upon. Take a moment to think about that. The universe doesn't stop being because it is empty. It continues simply because it must. Space expands. Time flows. The equation holds. Even at the end of matter, the rules remain eternal. And so the universe drifts further into quiet. Not dead, not broken, but at rest. The last solid thing has become energy, and energy has become silent. The story of matter has ended exactly the way it began, in light. Long after the final atoms have decayed, the only recognizable objects left are the black holes, immense, invisible wells of gravity scattered across the emptiness. They are the last engines of energy in an otherwise frozen universe. Every black hole holds the mass of entire stars, sometimes of entire galaxies, compressed into a region smaller than a grain of sand. Their gravitational pull is so intense that not even light can escape. Yet even these giants are not eternal. According to Stephen Hawking's prediction in 1974, black holes emit faint radiation due to quantum effects near their event horizons. This process, called Hawking radiation, allows a black hole to lose energy very slowly over unimaginable timescales. Let's break down what happens. At the edge of a black hole, the vacuum of space isn't truly empty. Quantum physics tells us that particles and antiparticles constantly appear in pairs. Tiny flashes of existence that annihilate almost instantly. Normally they vanish back into nothing. But near the event horizon of a black hole, one of these particles can fall inside while the other escapes. To an outside observer, it looks as though the black hole has emitted a particle, a faint glow against the dark. That escaping particle carries away energy, and the black hole shrinks just a little. For small black holes, this process happens relatively quickly. But for the supermassive ones, those billions of times heavier than the sun, it takes an extraordinary amount of time. Roughly 10 years or more before the last one evaporates completely. When that happens, each will end in a final brief flash. Imagine this moment. The cosmos, dark for untold ages, briefly sparkles again. A single flash here, another there, scattered across a sea of blackness. Like the faint echo of creation, repeating itself one last time. These are the final lights of the universe. After they fade, there will be no more energy gradients, no more radiation strong enough to warm even the smallest particle. What remains will be pure space, an expanding, almost featureless vacuum filled with a diluted background of low-energy photons and neutrinos. At this stage, physicists sometimes refer to the black hole era giving way to the dark era, a period so long that even words like age or era failed to describe it. The universe has crossed into true timelessness. And yet, there is something fascinating about this. Even in total darkness, physics continues to work flawlessly. Quantum fields still fluctuate. Virtual particles still appear and disappear. The fundamental constants, the speed of light, the Planck constant, the gravitational constant, all continue to define the structure of reality, even when there's nothing left to structure. This is what eternity really means. Not infinity filled with activity, but infinity filled with persistence. The faint glow from the last black holes will fade completely, and then, for the first time since the Big Bang, the universe will be truly dark. No stars, no heat, no time that matters. Only the gentle hum of physics, endlessly repeating its rules across a silent, frozen void. Now, pause for a moment and think of what that means. All of human history, all the fires of the stars, all the colors of galaxies, they existed for a blink. And yet, the laws that allowed them to exist continue, unchanged, perfectly stable. Even at the end of everything, the universe remains consistent. That is its beauty. It doesn't need to shine to exist. After the last black holes fade away, the universe continues its slow and steady growth. Expansion has never stopped. It began in the first second of the Big Bang, and has carried on relentlessly through every era. Now, with no matter left to resist it, expansion becomes the universe's only remaining motion. Space itself stretches. Every point in the cosmos moves away from every other point, not because anything is flying through space, but because space itself is growing. It is a strange concept to imagine our galaxies once drifted apart within space, but now space is what separates the very fabric of existence. Every wavelength of light, every tiny fluctuation is stretched along with it. What was once energetic radiation has now become unimaginably faint. Physicists describe this using the term cosmic redshift. As the universe expands, the wavelength of every photon lengthens. Red light becomes infrared, infrared becomes radio waves, and eventually, those radio waves grow so long that they carry almost no energy at all. The speed of this expansion depends on something called dark energy, a mysterious force that makes up about 70% of the universe today. In the far future, it dominates completely. As matter vanishes, dark energy's effect becomes absolute. It pushes space outward faster and faster, accelerating the growth of emptiness itself. At first, this acceleration might sound like movement, like something happening. But in truth, it turns the opposite. The more space expands, the less energy anything has to move within it. Wavelengths stretch, interactions stop, and the last traces of motion slow toward nothingness. This is what physicists mean when they talk about the cosmological horizon. Because of dark energy, there are regions of the universe we will never see. Not because they are hidden, but because they are receding faster than light itself. Every galaxy that once shared the cosmos with us will eventually vanish beyond that horizon. If you could somehow observe this final state, you would see no galaxies, no stars, no light, only the black void of infinite distance. The radiation that fills space is so weak that its temperature is effectively 0 Kelvin. But expansion does not stop there. It continues eternally. Space grows, thinner, flatter, smoother. Quantum fluctuations are those tiny blips of energy that once created entire universes become so rare and so weak that even they seem to vanish. And yet, even here at the edge of forever, the universe still follows the same principles it always has. Einstein's relativity still governs space-time. Quantum mechanics still defines energy. Now, take a moment to think about what that really means. All the complexity we ever known now stars, galaxies, life, came from tiny imperfections in the early universe. Slight differences in density led to gravity, and gravity built everything. But with expansion stretching everything toward uniformity, those differences are erased. The cosmos returns to what it was in its beginning, simple, featureless, pure. And yet, this time, Itan's not a beginning. Ita's a conclusion. The same perfection reached from the opposite direction. The endless expansion is not destruction. Itan's balance. All energy, all motion, all history, spread evenly across a canvas that never stops growing. If you could stand in this infinite dark if you could feel the scale of it you would not sense chaos. You would sense calm. The universe has finally reached what every system seeks: equilibrium. No more collisions, no more births, no more deaths, just an infinite expanding silence. The final rhythm of everything that ever was. At this stage of the universal's life, expansion continues unsmooth, infinite, unstoppable, but something subtle begins to happen. Change slows, differences fade, and with that, time itself starts to lose its meaning. To understand this, let us recall what time really is. In physics, time is not an independent thing that flows by itself. Time is a measure of change. When something moves, decays, oscillates, or transforms, we perceive that difference as the passage of time. But when everything stops changing, when energy no longer moves from one place to another, there is nothing left for time to measure. The universe, now cold and uniform, has reached that point. At the beginning of all things, time raced forward with violent speed. The Big Bang was an explosion of imbalance, temperatures, densities, and forces colliding in every direction. Stars were born, burned, and died. Galaxies spun and collided. Every reaction, every difference, gave time something to count. But now, those differences are gone. All energy has spread evenly. All motion has slowed to near stillness. This is not the end of time. It's what physicists call thermal time symmetry. In simple terms, the universe has become so uniform that forward and backward no longer matter. Nothing defines a direction for time anymore. If you were to exist in this far future, and somehow think, you would not feel time passing. Every moment would be identical to the one before it. The universe would appear frozen, not because it has stopped existing, but because it has reached perfect stillness. Think of it like a clock with no ticking hands. The mechanism is still there, but there's nothing left to move it. From a cosmological perspective, this marks the heat-death, not the destruction of the universe, but the erasure of all distinctions. Entropy has reached its maximum. The cosmos has achieved absolute balance. Let us put that in scale. In our current age, the temperature of the cosmic background radiation is about 2.7 Kelvin A, just a few degrees above absolute zero. In this future, it will be a billion times colder than that, approaching 10 degree Kelvin. At that temperature, even quantum motion slows to a whisper. Atoms are gone. Radiation is stretched thin beyond recognition. Only the fundamental fields the mathematical fabric of existence remain. But even then, quantum mechanics refuses to be completely silent. Tiny, unpredictable fluctuations still flicker through the vacuum, waves of potential energy appearing, vanishing. They are weak, almost meaningless, but they never stop. And so, the universe still exists. It has not ended. It has simply lost its sense of before and after. For the first time since the birth of time itself, The universe is timeless, not static, but beyond measure. Try to imagine that. A place where nothing changes, where nothing moves, where the very word I know van no longer applies. It is not death, it taught something quieter than death. A silence so complete that it has become the natural state of everything. And yet, in that silence, is still potential. The same quantum fields that once gave birth to galaxies still exist. And as long as they exist, something could one day happen again. The universe, for all its stillness, never truly stops dreaming. The universe has gone quiet, but quiet does not mean empty. Even now, after the stars, after the galaxies, after the last remnants of matter, the vacuum of space is not truly void. It still lives in a way that is invisible, but profoundly real. To most people, vacuum means nothingness. But in physics, the vacuum is not empty space. It is the lowest possible energy state of reality itself. Even when every atom and photon has vanished, the vacuum remains filled with fields, the deep structure from which all particles emerge. Quantum field theory tells us that every particle we know, electrons, quarks, photons, is just a ripple in one of these fields. And fields can never be completely still. According to the Heisenberg uncertainty principle, energy and time can never both be precisely known. That means that, even in total emptiness, there must always be tiny fluctuations, brief flashes of brief existence that appear and vanish before they can be measured. These are called quantum vacuum fluctuations, and they are the heartbeat of the universe's most silent state. In this eternal darkness, pairs of particles and antiparticles continue to flicker into being and annihilate each other in fractions of a second. They do not produce heat, they do not emit light, and they do not build structures, but they are there, the faint static of existence itself. If you could somehow see this vacuum, it would not look black or blank. It would shimmer faintly with virtual motion, countless quantum ripples too fast and too small for any observer to grasp. This is the zero-point energy of the cosmos, the minimum vibration that reality cannot suppress. And this energy may not be meaningless. Some physicists believe that dark energy, the mysterious force driving the expansion of the universe, could be the large-scale effect of these vacuum fluctuations. Even now, in the coldest and quietest era imaginable, that same energy still pushes space to expand, not stopping, not slowing, but continuing forever. Eton's remarkable too. Think that the same quantum restlessness that once gave birth to galaxies still hums beneath everything, even at the end of time. Now let us look deeper. The vacuum is not a flat sheet of nothing. It is a sea of potential. Inside it, particles can tunnel in and out of existence, fields can momentarily spike, and entire regions of space can gain or lose energy spontaneously. This idea is not just theoretical. Experiments on Earth, like the Casimir effect, have shown that even empty space between two metal plates contains measurable pressure from these fluctuations. That means what we call anything has structure, pressure, and energy. In the far future, when the universe is unimaginably old, this quantum energy will still be there. The only thing that truly never ends. But it also means that emptiness is unstable. Given infinite time, a quantum fluctuation could, in theory, trigger something extraordinary, the creation of a new universe. Cosmologists call this idea vacuum decay or quantum tunneling, a tiny bubble of higher energy vacuum forming spontaneously within the old one. If that happened, would expand at the speed of light, creating a brand new cosmos with its own physical laws. We would not see it coming. It would simply rewrite reality in an instant. It is a haunting thought, that the cold end of our universe might one day spark the birth of another, that even silence might contain the seed of sound. The vacuum, it seems, is never finished. Even at its calmest, it is alive, restless, unpredictable, eternal. If you take one thing from this, let it be this: the universe never truly ends. It changes its form over and over, guided by the same simple rules that began it all. The stars may die, the matter may dissolve, but the vacuum, the quiet foundation beneath everything, keeps breathing. And in that breath, the possibility of something new always remains. The universe, as it exists now, has reached its quietest and most balanced form, a sea of expanding emptiness filled only with the hum of quantum fields. It would seem that all things have ended, but in physics, endings are rarely absolute. Even in this infinite stillness, the vacuum remains alive with potential. Tiny fluctuations, restless heartbeat of quantum mechanics, continue to appear and disappear across the fabric of space-time. Most are harmless, fleeting ripples. But given enough time, and remember, the universe now has all the time there is until one of those fluctuations could become something extraordinary. Imagine a small region of the vacuum, a patch of space, where the energy briefly rises above its lowest possible level. If this new state of energy is more stable than the one before it, the laws of physics dictate that it will expand, replacing the old vacuum with the new one. This event is called vacuum decay, and it is one of the most profound possibilities hidden within modern cosmology. If it were to happen, the result would be the birth of a new universe. The moment that bubble forms, it begins to expand faster than the speed of light. Its boundary, the wall between the old vacuum and the new, becomes a cosmic frontier, sweeping across existence in an instant. Inside that bubble, the energy density is high, and the conditions mirror what we believe existed at the very beginning of our own cosmos. A true Big Bang, but without the need for a singular explosion. Space itself would inflate, forming new particles, new forces, and new laws of physics. From infinite silence, a new storm of creation would begin. This idea is deeply connected to cosmic inflation, the theory that explains the rapid expansion of our universe shortly after its birth. According to some cosmologists, our own universe might have begun as one such quantum fluctuation, a single bubble that formed within a larger vacuum field. And that would mean the death of one universe could simply be the transformation into another, not an ending, but a transition. Let us pause for a moment and imagine this cycle. Billions of years of light and life, followed by a slow fading into stillness. And then, from that perfect stillness, a single spark, one quantum event giving rise to a brand new reality. Every beginning could be born from an ending. Every ending could hold the seed of something new. In theoretical cosmology, this is sometimes called the multiverse hypothesis. The idea that our universe is just one of countless others, each born from fluctuations in a vast cosmic foam. Each bubble universe could have its own constants, its own physics, even its own dimensions. Some might expand forever, like ours. Others might collapse quickly. But all of them, in some sense, are connected, born from the same underlying quantum sea, where energy never truly dies. It's humbling to realize that even in the coldest, most desolate version of reality imaginable, the potential for creation still exists. Not because of miracles, but because of physics. The laws that govern decay also allow rebirth. The symmetry of the universe demands that nothing, not even nothingness, can stay unchanged forever. And perhaps, far beyond the limits of what we can imagine. This has already happened. Maybe, from our universe's silent end, countless others have already begun expanding, evolving, burning with light, and waiting, one day, to fade just as we have. If that holds true, then the cold end of the universe is not a graveyard. It is a nursery, a place where existence itself learns to breathe again. And even if no conscious being ever sees that rebirth, the act of it, the return of light, of time, of possibility, is the universe's way of saying that it never truly stopped. The cycle continues. The silence is not forever. Somewhere in the endless dark, the first spark of a new dawn is already beginning. If the universe can be born from the remains of another, then perhaps it has never truly had a beginning or an end. What we think of as earthy and the long fade into cold and silence, might simply be one phase in an infinite cycle, a cosmic heartbeat that expands, cools, collapses, and begins again. This idea is not new. Ancient philosophers once imagined the cosmos as eternal, breathing in and out like a living being. But now, through the lens of physics, this vision takes on new depth. Let us consider how it might work. Every universe begins as a fluctuation in a larger quantum field, a bubble of energy that expands rapidly, producing space, time, and matter. That universe lives its lifespan. Stars form, galaxies evolve, life appears and fades. Then entropy, the great equalizer, spreads energy evenly until everything cools into balance. At that point, one of two things can happen. The universe continues expanding forever until it becomes a thin, quiet vacuum, or the vacuum itself transforms, collapsing or shifting into a new state that triggers another Big Bang. In both cases, creation is reborn. Modern cosmology offers several interpretations of this cyclic reality. One of them is the Big Bounce theory. Instead of a singular Big Bang at the beginning, the universe may oscillate, expanding, cooling, and then contracting under gravity, only to explode outward again. Each bouncer could erase the traces of the universe before it, while keeping the same physical laws at its core. Another idea comes from eternal inflation, a concept introduced by physicist Alan Guth. According to this theory, the inflationary field that caused our universe to expand never stopped completely. While our local region cooled and formed galaxies, inflation continued elsewhere, endlessly generating new universes in other regions of the quantum field. In this view, creation never ends all. It simply keeps branching forever. Now think of this not as repetition, but as evolution. Each universe could differ slightly from the last. Different constants, different dimensions, different possibilities. Some universes may collapse quickly, others may live for trillions of years. But in every case, the underlying energy, the foundation of existence, remains eternal. This brings us back to the second law of thermodynamics. Entropy increases with time. In one universe, that may lead to heat death. But across an infinite ensemble of universes, entropy is constantly reset by creation itself. The cycle feeds its own renewal. You can imagine it like an endless ocean. Each wave rises, peaks, and falls back into the water, only for another to rise again. The individual waves come and go, but the ocean remains. Perhaps that is what existence truly is. Not a line with a start and finish, but an unbroken flow. And maybe, just maybe, we are part of that rhythm. Every atom in your body once belonged to an ancient star. And every photon you see today was born in a moment of creation. When this universe fades, its energy will not vanish, it will transform. And someday, in another cycle, it will return as light again. This idea is both comforting and humbling. It means that the universe never truly ages. It only transforms. No energy is lost. No law is broken. No moment is wasted. The cold end of the universe, then, is not the end of everything. It is the reset. The quiet turning of a page. Perhaps, somewhere far beyond the boundaries of our understanding, a new universe is already blooming. Its first atoms forming, its first stars igniting, its first observers looking up and wondering how it all began. And in that distant beginning, they might call it the Big Bang. Not realizing that they are living inside the echo of an older universe's last breath. In this infinite cycle, every ending is a beginning, and every silence carries the promise of a new sound. The universe, it seems, never truly sleeps. It only pauses before beginning again. If the universe truly moves in endless cycles, if creation, decay, and rebirth are woven into the fabric of time itself, then what happens to information? When matter dissolves, when stars vanish, when even light fades into cold radiation, does the record of existence vanish with it? Physics gives us a surprising answer. No. Information, it seems, is one thing the universe refuses to destroy. Let us explore why. Every event that has ever occurred, every particle collision, every fusion reaction, every thought, every photon, leaves a mark on reality. Not a visible one, but a quantum imprint, encoded in the wave functions and entanglements that connect everything. Even when particles vanish, their information is believed to persist in some form, distributed through the very geometry of space-time. This idea is known as the conservation of information, one of the deepest principles in modern physics. It states that the total information contained in the universe can never be lost. It can only change form, just as energy does. Think of it like this. When you burn a piece of paper, the paper disappears. But the atoms, photons, and heat it releases still carry the same total information, rearranged into a different pattern. The structure changes, but the sum of what existed remains constant. The same, physicists argue, must be true on a cosmic scale. When a star collapses, when a galaxy evaporates, or even when a black hole consumes matter, the information that defined those events cannot simply vanish. It must remain encoded somewhere in radiation, in fields, or in the subtle structure of space itself. This leads to one of the most famous debates in modern cosmology, the black hole information paradox. For decades, scientists believed that anything falling into a black hole was lost forever. But Stephen Hawking's discovery of black hole evaporation raised a troubling question. If black holes emit radiation and eventually disappear, what happens to the core information they once contained? If information were truly destroyed, it would violate the most fundamental rule of quantum mechanics. So physicists like Leonard Susskind and Juan Malacena proposed something extraordinary, that information might not be lost, but encoded on the surface of the black hole itself. This became known as the holographic principle. The idea that the three-dimensional world inside a black hole, or even inside the universe itself, might actually be a projection of data stored on a two-dimensional surface. In other words, reality could be a vast cosmic hologram where every bit of information is preserved in the geometry of space-time. Now let us return to the far future, to the cold end of the universe. Even when all matter decays and radiation fades, the quantum state of the vacuum, the fundamental fabric of existence, still holds the accumulated information of everything that ever was. Not in words or images, but in patterns of energy, entanglements, and probabilities. Every interaction leaves a trace, however faint. The cosmos itself becomes a kind of memory field, not alive in any conscious way, but structurally aware of everything that has occurred within it. If one could somehow read those quantum states, one could, in principle, reconstruct the entire history of the universe. It has an almost poetic symmetry. In the end, when all form disappears, all memory remains. Perhaps this is what gives the next universe its blueprint, the encoded data of what came before, stored invisibly in the quantum sea. When the next fluctuation arises, when a new universe inflates from the vacuum, that memory, the pattern, might subtly influence its formation. Maybe the toss, why certain physical constants are the same everywhere. Maybe every universe inherits a faint genetic code from the last. And if thou's true, then we are all part of an unbroken chain of memory, stretching backward and forward through eternity. Nothing ever truly leaves, it only changes shape. You, me, the stars, all of it written into the language of physics, etched into the structure of space-time itself. When the light finally fades, the universe does not forget. It remembers, perfectly, endlessly, quietly. By now, the universe has become almost entirely still. There are no stars, no galaxies, no dust, only the quiet hum of quantum fields, stretching across an infinite expanse. And yet within that quietness, there is something extraordinary, the memory of everything that ever existed. Physics tells us that information is never lost. That means that in some form, the universe remembers its entire past, every atom that formed, every photon that traveled, every event that unfolded since the Big Bang. It is all still here, encoded into the fundamental structure of space-time. This is not a poetic metaphor, it's a physical truth rooted in quantum mechanics and relativity. Even when the universe appears empty, it carries an invisible record, like a cosmic archive made of probabilities and fields. Each interaction between particles leaves behind a faint trace in the state of the vacuum. Those traces add up, layering across time, until the whole fabric of existence becomes a tapestry of memory. To understand this, imagine throwing a pebble into a calm lake. Even after the ripples fade, the water is never quite the same. Molecules have shifted, currents have changed, and the surface carries a microscopic record of what happened. Now expand that idea to the universe itself. Every burst of light, every gravitational wave, every fluctuation in quantum space leaves behind a subtle distortion, a memory ripple that never fully disappears. This is how the universe remembers itself. Some physicists believe that this information is stored in the quantum entanglement of particles, the mysterious phenomenon in which two particles remain connected even when separated by vast distances. Entanglement does not just link individual particles. It weaves space and time together into a continuous network of relationships. In this sense, the universe is not a collection of separate things, it's a single interconnected system, bound together by its own memory. If we could somehow look at the total quantum state of the cosmos, something far beyond human comprehension, we would see that it contains the full description of its entire history. The rise and fall of galaxies, the birth of life, the cooling of the stars, all of it still exists as encoded information within the vacuum. This also means that, in some deep and subtle way, the universe is self-aware. Not in the conscious, human sense, but in the physical sense that it carries complete knowledge of itself. Every point in space contains information about every other point. Every piece of reality reflects the whole. This concept is sometimes called holographic reality, based on the holographic principle, the idea that the entire three-dimensional universe can be described by data on its two-dimensional boundary. In other words, reality might be the ultimate recording, a projection of its own stored information. Even at the cold end of time, this information remains. The photons that have traveled endlessly still carry their history. The curvature of space-time still encodes the memory of every mass and every event that ever existed. The universe never forgets its own past on. It simply stops changing it. Now think about what that implies. If a new universe is born, through a quantum fluctuation or a vacuum transition, it might inherit this stored information, reshaping it into new laws, new structures, new beginning. That means, in a very literal sense, every new universe might remember the one before it. Perhaps they tell us why the constants of physics are the speed of light, the charge of the electron, the strength of gravity seem so precisely tuned. They may be the echoes of previous realities, passed forward through the deep memory of existence. Eton's a humbling thought, that even as the cosmos fades into darkness, it carries its entire story within it. Perfectly encoded, never erased. We are part of that memory, written into the same equations that govern galaxies and atoms alike. And in that way, the universe does not merely exist. It remembers. It remembers what it has been, what it has lost, and perhaps what it will one day become again. The silence of the end is not amnesia, it is reflection. A timeless moment in which the universe, after eons of change, holds its entire history in stillness. Everything that ever was is still here, just quieter now. At the cold end of the universe, all structures have dissolved. No stars burn, no galaxies glow, and even matter itself has vanished into radiation. Only quantum fields remain, still fluctuating, still real, still following the laws written at the dawn of time. In this quiet infinity, one question remains. Who or what is there left to observe the universe? In quantum mechanics, observation has a very specific meaning. It does not require consciousness in the human sense. It simply refers to interaction. When two systems exchange information, when a particle collides, when light reflects, when a field responds, that is a form of observation. Reality, at its deepest level, is not about things existing alone. It's about relationships. But now, in this late epoch, those interactions have nearly ceased. Particles are too far apart to collide. Light is too stretched to strike anything. The fields are quiet, uniform, unchanging. And so, the universe has become almost unobservable, not because it has disappeared, but because there is nothing left for it to interact with. Without exchange, information no longer moves. Without motion, time loses its direction. Without direction, the concept of observation dissolves. Yet the equations still hold. The fabric of space-time still contains its patterns. The information of every event, every structure, every moment remains woven into the vacuum. It no longer changes, but it is still there. In that sense, the universe itself becomes the final observer. It does not think, it does not perceive, but it contains. All that has ever happened is recorded in its structure, perfectly conserved by the laws of quantum information. Physicists sometimes describe this as the wave function of the universe, a single mathematical entity that describes every possible state of everything that exists. It is timeless and complete. Every probability, every history, every observation is encoded within it. Even if no conscious being survives to witness the universe's last moments, those moments still occur. Reality does not depend on our awareness. It is defined by the consistent unfolding of its own laws. And those laws ensure that nothing, not even knowledge itself, is truly erased. In this way, the universe observes itself simply by existing. Its geometry is memory. Its structure is record. Its persistence is awareness. If we step back and think of consciousness as the ability of matter to reflect on itself, to create internal models of the external world, then perhaps consciousness was never separate from the cosmos. Every neuron that ever fired, every atom that carried an impulse, every photon that struck an eye, all were expressions of the universe, knowing itself through physical processes. Now that those processes have ended, that reflection has quieted on, but not disappeared. The memory remains encoded in the curvature of space-time, in the faintest quantum states, in the quiet hum of the vacuum. It is not a human awareness anymore. It is something deeper, structural, eternal, absolute. So even at the end, there is still observation. Not by an eye, not by a mind, but by existence itself. The universe, vast and timeless, is both the observer and the observed, the recorder and the record. The final truth, then, is not that everything ends in silence. It is that silence itself is full of information. Every vibration that ever was still echoes faintly through the geometry of being. Every light that ever shone still defines the shape of darkness. And, in that sense, the universe, though frozen, remains aware. Not aware of something, aware as something. The quiet end is not emptiness. It is the ultimate realization that existence and awareness were always the same thing. When everything else is gone, when the last traces of matter and radiation have faded, what remains is not truly, nothing. It is space itself, stripped of content, but not of structure. The universe at this stage is a vast geometric field, silent, cold, and nearly featureless, yet still perfectly real. To understand what that means, we need to look at what space actually is. In Einstein's general theory of relativity, space and time are not a passive background in which things happen. They are a single, flexible entity, Space-time, Every planet, every star, every galaxy once curved this fabric slightly, creating the gravity that shaped their motion. But now, those sources of curvature are gone. No stars remain to warp the geometry. No galaxies to twist it. Space-time has relaxed, smooth, almost flat. However, almost, is the key word. Even in total emptiness, space-time retains a shape. The expansion of the universe gives it curvature on the largest possible scale. And that curvature continues to evolve, even when no matter remains. This is the quiet legacy of cosmic geometry, the structure of nothingness. Imagine stretching a sheet of fabric so far that all its folds, wrinkles, and curves disappear, leaving a perfect plane. That is the asymptotic fate of space. Smooth, uniform, infinite. Yet beneath that stillness, the fabric is still stretching. Space continues to expand. Because of dark energy, the mysterious force that causes distant regions to accelerate away from each other. Physically, dark energy can be described as the energy of the vacuum itself, a constant density of energy that remains even when there is nothing left. This energy gives space-time a gentle outward push, ensuring that expansion never ends. As a result, even the coldest, emptiest universe keeps growing. At the smallest scales, quantum mechanics adds complexity to this simplicity. Even in perfect vacuum, space-time is not truly smooth. It fluctuates, not in space, but in its own geometry. This phenomenon is sometimes called quantum foam, a ceaseless bubbling of microscopic distortions that appear and vanish in timescales shorter than Tanaya seconds, the Planck time. You can think of this as the universe breathing at its most fundamental level, tiny ripples in the curvature of reality, invisible but unavoidable. They are the same ripples that once allowed entire universes to be born out of the vacuum. This is the geometry of nothingness, not empty, but active, not cold in the emotional sense, but calm on, perfectly, balanced between expansion and rest, motion and silence. Even with no particles, no radiation, and no events, space-time retains measurable properties. Metric structure, which defines distances and durations. Curvature, set by the cosmological constant. Quantum fluctuations, ensuring that zero is never truly zero. So while the human imagination thinks of I nothing as an absence, physics sees it as a state a structure defined by equations that still apply. In a way, the ultimate destiny of the universe is to become pure geometry. Canvas without paint, but still stretched across infinity. Now imagine drifting through that geometry, no up, no down, no light, no heat. Everywhere is the same, every direction identical. Yet the fabric of space continues to expand, creating more of itself endlessly. This is not chaos or destruction. It is order in its most perfect form. A universe without form is still a universe with rules. The final landscape of reality is not a void, but an equation a silent balance of geometry, energy, and time that continues forever, even when nothing else does. The end of everything then is not a blank page. It is the purest expression of existence possible structure without substance, order without motion, an eternity without change. The universe continues to expand, endlessly and effortlessly. There are no galaxies to mark the scale of this growth anymore, no stars to serve as points of reference. And yet, space stretches still not into anything, but as everything. At this stage, the idea of distance itself begins to break down. To measure distance, you need landmarks something here, something there. But when everything is smooth, uniform, and identical in every direction, the very act of measuring loses its meaning. Space grows, but there is nothing left in it. Expansion continues, but there are no observers to define how fast or how far. It is motion without movement, geometry changing without consequence. In the early universe, distance was full of meaning. Galaxies moved apart, but gravity still linked them. Light took millions of years to cross from one star to another. Distance shaped time, and time shaped the story of everything. But in this future, distance no longer defines separation because there is nothing left to separate. The universe is a smooth field, perfectly uniform. You could travel in any direction, and you would find only more of the same cold, structureless space expanding into more space. Even light, which once connected distant regions, has grown too faint and too stretched to bridge the gaps. Its wavelength is now larger than the visible universe itself. The concept of communication of one region influencing another has vanished. Physicists call this state causal disconnection. It means that every point in space has drifted so far from every other point that no signal, not even one traveling at the speed of light, can ever cross the distance between them. In other words, the universe has become fragmented beyond repair. Each region, isolated by expansion, becomes its own silent island on a self-contained bubble of space-time with no way to know that others exist. Even if you could somehow survive in one of these regions, you would never see or sense another. Your entire observable universe would be a featureless void, with no edge, no motion, no difference. The death of distance is not a sudden event. It is the quiet erosion of meaning itself. A slow fading of relationships. Every boundary once defined by physics dissolves until there are no a between sa left, only a. Oh, what does it mean for distance to die? It means that scale ceases to matter. The universe has expanded so much that expansion itself becomes irrelevant on. Every point stretches infinitely far from every other. And yet, paradoxically, nothing changes. In this final geometry, the equations of relativity simplify. Space no longer curves, it only stretches. Time no longer flows, it only exists. And every coordinate, every direction, becomes identical. This is what cosmologists refer to as de Sitter space a model of a universe dominated entirely by dark energy, expanding exponentially forever. In de Sitter space, horizons form boundaries beyond which nothing can ever be seen or reached. Each region of space-time becomes its own epochaton of reality, forever cut off from all others. Now imagine what that means for the concept of existence. If nothing can ever interact, does it make sense to say that distance still exists at all? When there is no comparison, no exchange, no perception, what is Farha? What is Anhusa? At this point, the geometry of the cosmos loses its scale, collapsing into pure mathematics. Distance becomes a number without reference. Space becomes an idea rather than a place. The universe has not vanished, it has simply transcended the need for measurement. This is the death of distance, not destruction but dissolution. Reality has expanded so far that there is no longer an elsewhere. Ein everywhere is equally unreachable, and so, in a sense, everything is here. The ultimate paradox of the cosmos. The larger it becomes, the less there is to measure. The more it expands, the more it becomes the same. The universe has achieved perfect separation, and in doing so, perfect unity. Even in a universe stripped of matter and light, there is still one final boundary that defines what can be known, the cosmic event horizon. It is not a wall, not a physical edge, but a mathematical limit. It marks the farthest distance from which light or any signal can ever reach a given point, no matter how long time endures. To understand the last horizon, imagine standing alone in an infinite, expanding universe. Light you emit travels outward, but because the fabric of space is stretching faster than that light can move, there comes a distance beyond which your light will never be seen. That distance defines your observable universe, your own cosmic bubble. In the early ages, when galaxies filled the night, horizons were enormous and full of meaning. Astronomers could look across billions of light years and still detect radiation from the Big Bang itself. But now, in this far future, even those cosmic echoes have faded. The last horizon has shrunk, not in size but in reach. Beyond a certain point, expansion carries all things away faster than any signal could bridge the gap. Every observer, if such an observer could exist, is forever isolated within their own pocket of space-time. This horizon defines the limits of cause and effect. Within it, the laws of physics still connect events. Beyond it, connection is impossible. There is no longer a single universe in the practical sense, but an infinite collection of silent, disconnected regions. Each one frozen in its own piece of eternity. Physicists describe this structure as a de Sitter horizon, a direct consequence of dark energy's dominance. Its radius depends on the cosmological constant, the measure of how fast space expands. If that constant never changes, then the horizon will always exist, marking the unreachable boundary of perception. But this boundary is not like the horizon of a black hole. Nothing dramatic happens when you cross it. There is no surface, no edge. It is simply the middle, place where expansion overtakes light, where communication ends and isolation begins. The fascinating irony is that this final horizon behaves, in some ways, like a black hole horizon turned inside out. While a black hole hides its interior from the rest of the universe, the cosmic horizon hides the rest of the universe from you. Each region becomes its own microcosm, complete, unchanging, unaware of the infinite beyond. Now imagine the physical implications of this. If the horizon defines what can ever be observed, it also defines what can ever be known. Beyond it, reality becomes not non-existent, but meaningless, because it can never affect or be affected by what remains within. In that sense, knowledge itself has a boundary, not a wall, but a limit written into the geometry of space-time. The photons that once crossed galaxies now drift outward, never reaching another observer. Every pulse of light, every signal of information is stretched beyond all recognition, absorbed by the ever-growing void. The universe, as it expands, hides itself from itself. Even the faint radiation of black hole evaporation, those last glimmers of energy, will eventually fade beneath this horizon, leaving nothing to see, nothing to measure. And yet, the horizon itself holds energy. Quantum theory predicts that every horizon, even one caused by cosmic expansion, has a temperature unimaginably small, but non-zero. This is known as de Sitter radiation. It is the faint whisper of quantum activity at the boundary of the observable world. Even in this ultimate stillness, the universe hums with one last, steady rhythm, a quiet heat of the horizon. It is strange to think that this almost featureless universe still carries a trace of warmth, a ghostly echo of the energy that once filled everything. That faint radiation is not enough to form structure or drive motion. It is merely the mathematical minimum that existence allows. The last horizon, then, is more than a physical limit. It is a mirror, the final reflection of what once was. A reminder that even when nothing can be seen, something is still there. A geometry still expanding, a fabric still humming, a law still holding. The universe does not collapse into nothing. It recedes into itself. The horizon is not the edge of reality, It taunts the edge of communication. Beyond it, space continues. But that space can never again be part of our story. The last horizon stands forever, marking the silent divide between what remains known and what lies forever beyond reach. And as the universe grows colder and smoother, that horizon too begins to fade, not in form, but in purpose. There comes a moment when even limits lose their meaning, because nothing remains to cross them. The universe has now reached a state where nothing visibly happens. No stars ignite, no particles collide, no light travels far enough to be seen. And yet, beneath the silence, the laws of physics remain exactly as they were in the beginning. Precise, complete, and unbroken. This is perhaps the most profound realization about the end of everything. The laws continue even when there is nothing left to follow them. From the smallest quantum fluctuation to the curvature of space itself, the same mathematical structure that once governed galaxies still defines reality. But now, there is no motion to calculate, no mass to attract, no charge to balance. The stage remains, the play has ended. To grasp this moment, we must remember that physical laws are not things that act on. They are relationships, descriptions of how entities behave when conditions exist for them to do so. Now, at the cold end of time, those conditions are gone. Temperature is uniform. Energy is distributed evenly. No gradients, no imbalances, no events. And so, while the laws still apply, there is nothing left for them to describe. Think of a piano in a vacuum. its strings still capable of vibration, its design perfect, but the air that once carried its sound is gone. The rules of music remain, yet no sound can form. That is the state of the universe now, laws intact, harmony silent. At this point, time has lost its operational meaning, because time is the measure of change, and there is no change left to measure. Space continues to expand, but expansion has no reference anymore. It is geometry without consequence, a function without output. The constants of nature are the speed of light, the Planck constant, the gravitational constant all persist. They are still woven into the fabric of space-time. But there are no photons to test the speed of light, no particles to experience gravity, no quantum field strong enough to reveal uncertainty. Every formula remains true, but truth itself has become abstract. If an equation falls silent in a universe with no one to solve it, is it still real? Physics answers, without hesitation, yes. Reality does not depend on activity. It depends on consistency. Even without events, the structure that makes them possible remains. Even without forces, the framework of interaction endures. This is the quiet persistence of natural law, eternal and indifferent. For billions of years, these equations produced everything: stars and galaxies, chemistry and life, thought and wonder. And now, after all motion has ceased, those same equations remain the only survivors. It is as though the universe has folded back into its own mathematics, a perfect balance where every value, every constant, has reached harmony. There is no tension left to resolve, no potential left to release. Entropy has achieved its final form, uniformity without exception. And yet, this is not annihilation. The field equations of general relativity, the quantum principles of uncertainty, the probabilities of wave functions all still define the shape of the vacuum. They do not vanish, they simply stop producing difference. From one perspective, this might look like death. From another, it is the ultimate order, a cosmos so balanced that no further evolution is possible. This is when laws go quiet. Not broken, not forgotten, but fulfilled. Every action that could occur has already occurred. Every motion that could exist has already faded. What remains is not the absence of physics, but the completion of it. Imagine a perfect equation written across infinite space. No symbols missing, no terms unresolved, no energy unaccounted for. That is the final universe, a state of eternal correctness. The cosmos no longer acts, it simply is. A structure of laws without events, of geometry without change, of time without passage. The silence is not emptiness. It is the still echo of a universe that has finally reached equilibrium with itself. The laws have not died, they have gone quiet because they have gone. Nothing left to say. In the beginning, there was light. Not metaphorically, truly, literally. The first photons burst forth from a newborn universe, carrying the story of everything that would ever exist. They traced the paths of stars, painted the surfaces of planets, and revealed the shape of time itself. Now at the end, the light has faded. No beams cross the darkness. No stars remain to ignite new dawns. And yet, something of that light still lingers. Its memory is written everywhere not as brightness, but as form. Every curve of space-time, every vibration of a quantum field, every faint whisper of the cosmic background still carries the imprint of light that once was. Photons may be gone, their wavelengths stretched beyond recognition, but their geometry, the paths they carved endures within the structure of the vacuum. You could think of them as footprints in an infinite desert. The traveler long vanished, the sand forever reshaped by their passage. Even now, in this silent and perfect cosmos, the memory of motion energy, and life remains etched into its bone. The frozen symphony still holds its luminous refrain, not audible, not visible, but there. For as long as geometry exists, the memory of light will never fade. Light was always more than illumination. It was information, connection, witness. Every photon that ever existed recorded an interaction between atom and atom, star and dust, life and sky. It was light that carried knowledge across the ages, binding together the universe's distant parts into a single radiant whole. Now, at the quiet end, when no eyes remain to see and no minds remain to wonder, that light still defines the shape of everything. The cosmos remembers, not through consciousness, but through structure, the eternal memory of motion, frozen to the calm. And maybe that is what eternity truly means. Not endless time, but the endless presence of what once was. Nothing ever disappears, It transforms, it fades, but it leaves its trace forever. The light of the first dawn lives still, buried deep within the curvature of space. The pulse of vanished stars echoes faintly in the geometry of silence, and the spark that once burned in every atom, every thought, every heart, exists as a pattern, as a part of the grand equation that will never die. The universe began in fire and ends in balance. What was once a storm of energy has become a sea of stillness. But the story, the shape of what was, remains perfect, complete, and unbroken. Perhaps that is how it was always meant to be. The universe was never about permanence. It was about transformation, about turning chaos into order, motion into memory, noise into silence, and finally light into structure. And in that silence, that eternal, unchanging calm, the universe is not gone. It is fulfilled. The lights have gone out. The stars have finished their long performance. But their song, their warmth, their story art will never be lost. Because even at the cold end of everything, the memory of light still shines.